This is the Galloway that most people see. A land of beauty, a land of hills with some of the oldest rock in the world, a joy to behold and walk in. A land of seascapes, bringing life to the towns, a land of lochs to sail and fish. Woods and forests bring their own usefulness and host their own springtime vision. Streams and rivers bursting with energy, put to use in our service. A land too of memories, ghosts of past civilization. Long dead ships whose bones rise out of the sea. Spooky graveyards. A land where they build wooden men and burn them. This is the land of the Wicker Man. Galloway is where the film of the same name was made. Galloway is where the Wickerman Festival is held each year. And if it wasn't for the Wickerman Festival, there would have been no ram pump and no mechanical cow.
Up the back.
Let me introduce to you in the red corner Jamie Gilroy, and in the blue corner his neighbour John Higgs. Jamie owns the Wickerman Festival site and organises the show. John is an engineer. Jamie was looking for a new attraction for the 2005 festival, and he put the challenge of building a mechanical cow to John, who took it up and added a ram pump to drive it. Thus was conceived the mechanical water cow, the world's first Automoo-ton. Over the cow. The project started with a little under 3 months to go before the festival started, with John Higgs working up a design and figuring out where it would go on the festival site. It needed a dam to provide a 1.8 metre head of water.
We could put a dam further down.
And a location over the stream narrow enough to take the legs of the cow, but near to where the pump would go. Not easy. It needed shape and form, moving parts, water courses and counterweights. Not easy.
Well, that's 12 feet. It's a rather wide point, but if I take it further down, I can't get the same height.
What a puzzle. The ram pump that John was designing uses a 1.8 metre head of water. The pumping element, that is the impulse valve, does its work by generating shock waves and will lift water up to more than 6 metres. John's calculations have worked out the weight of water and the sizes of forces involved. There was going to be a lot of banging at the working end. It was clear that heavy concrete units would be needed to hold the valve, the pipes running into it, and the accumulation tower. Otherwise, the whole the ram pump would just slip downstream. So it was back to Auchengool, John's farm, to start the construction phase. It was going to be a big job, so first, some coffee. Then framing and shuttering for casting the concrete plinth. This was all made very carefully to pre-planned dimensions with slots for the components to fit into. Reinforcing bar was cut and fitted for added strength. And thinking ahead, short lengths of chain were cut and set to provide lift points for the JCB. This plinth certainly was going to be heavy. When it comes to shovelling, it's awfully handy to have a cameraman around. Pouring concrete the primitive way. John made this tamping device to keep the concrete liquid until all the voids were filled and air bubbles eliminated. The plinth was left to harden for a couple of days, and then it was time to see what was there. Taking the shuttering off is a vigorous activity and very good for the soul. At times brute force, at other times ingenuity. There's nothing like a good battering, a ripping, pulling, unscrewing made easy, wanton destruction, jemmying, prizing, levering, gasping, panting, The wrecking goes on. Will it never end? It seems longer to demolish than make. The concrete certainly looks well cured and neatly made. Here's the ingenuity combined with yet more force. Will it never end? There always seems to be more to do.
There we are.
But in the end, it's voila.
So there we have the pump base. May God bless all those who get drenched by her.
Finally, it got taken to the Automoo swamp to soak and cure some more, while the next batch of components got made. Starter for 10. You can see as the pump was assembled for test that there are a lot of components and a lot more bits of heavy concrete. So it was back to shuttering. This time some of the bits had pipes set in, all to the plan, but care had to be taken to ensure that no concrete would block things up. That meant plugs. Some could be simple discs of wood, but some were more complicated wooden plugs. John, as ever, had a solution. In the depths of the old farm buildings was his secret weapon, a very capable lathe brought with him at considerable difficulty from Leicester and now ready for service. First, find a piece of wood, not hard on a farm, and then having set up the machine, start to shape it according to plan. This is a reasonably straightforward shape, but it has to fit. A bit of trial and error here just to get it perfect. And then back to finish the shaping. Final touch to complete the job.
Slacken the centre off, and there we are. And holds it in place, and when the concrete is set we should be able to pull that out.
Note that should be able to pull it out.
In there.
Anyway, it was back to the moulds and concreting. John should have been good at that by now. Pouring.
Just start shoveling.
Levelling. Driving out bubbles. Liquefying. Then curing. What have we got? Disassemble. Now the removal of the plug. Bit of brute force. Oops, that was the handle coming off. Some plugs were easier. This was the little wooden disc. Up she comes. Anyway, back to work. This time John thought a welded end to the rod would work. More brute force. Well, the end was good anyway, but John couldn't do it. If at first you don't succeed, bring in the heavy brigade. B was put to work. But the plug must have swollen because it wouldn't shift. Last resort now. If it's wet, dry it and burn it. This would take a while, so the rest of the dismantling could proceed. In fact, it burned for hours and hours, weakening all the time. At last it was time to have another go. Would it or wouldn't it?
So let's see if fire and brimstone have sorted this. There we are.
Thank goodness. Now we can get on with some other bits of the pump. This old barrel was going to be the reservoir to collect the water at the right height before it ran downhill to the pump. First, the top had to come off. Then, looking at the bottom, an outlet had to be made for the water. A cutting job, followed by assembly and fitting the outlet spigot.
This ring goes inside.
The water is to lubricate the rubber seal while the centre is cut out.
Yes.
It worked nicely.
And this fills in the space between the rubber seal and the spigot, and this flange goes over the top of that. We'll clamp it in place and drill it.
Here was another nice job for the cameraman. Heaven knows what had been in the barrel originally. Anyway, the spigot was assembled properly, and that's what mattered. The inlet pipe had to be stepped down from the main supply with a joining piece, and here is how it all looked on site. So the next task was to arrange for the inlet pipe to fit. John Higgs was away from home, so the oven was pressed into service to soften the plastic. That got moulded to the shape of the barrel by being held in place while it cooled. a hole had to be drilled to take the pipe. Just making sure that is measure twice, cut once. Does it fit the pipe's diameter? Yes, so we can make the spigot from a section of it. Then sealant was squirted round the spigot. Well, here goes the cameraman again, into the submarine. Soon the spigot was all bolted in place. There's always an audience at a farm. This is where the reservoir sits.
Tighten it up.
The chain and bottle screws were to cope with the anticipated shock waves in the system. The pump operates to force water into an accumulator tower. To prevent the water flowing back into the pump, there was to be a non-return valve made from rubber and a stainless steel plate punctured with drilled holes. This is the plan for cutting the plate and seals. John used his press drill for maximum accuracy, starting with sealing rings.
There we are.
Then it was time to cut the shape of the plate. The cutting tool is an angle grinder clamped to a workmate.
That's right. All right. Ah, there we are.
Yeah, good.
This is the drill plan for the plate, a complex pattern, and because stainless steel can be difficult material to work, requiring great care. The punching is to mark the plate so that the drill will be accurately placed. Drills for stainless steel have to be sharp to avoid hardening of the work. For the same reason, they have to be kept lubricated and cool. The rubber non-return valve flap needs a fulcrum. That would be this rod.
There. I think I missed. flap valve diaphragm goes on top. When the water comes through, it opens like this, so we need to fasten that on. It blows open the valve on both sides together, like so, and once the impulse has passed, that flaps down and stops the water going back down it again. So, enter this.
On top of the valve went the connection to the tower. It would have some additional fittings.
This.
It was a good tight fit. Again, chains and bottle screws to take the shock waves. Between the connection and the tower is a flexible link. The idea was to absorb some of the shock force, and here was piped the same diameter as the accumulator tower. Next task was to make an outlet, for the moment to act as flow control, but when live to drive the car itself. Again, standard piping, but with modifications. This stopper would enable John to control the flow by pushing it in and out. Press drill comes into its own again to cut a hole to take the outlet. All the orange pipes were standard 6-inch diameter drain pipes. This machine removed the thread from the domestic pipe fitting so that it could be glued.
See if it fits. There we are. Yeah. Hopefully this will be, yes, fastened onto the side of the tower here. And plug a piece in here. This one plugs on there. There's another O-ring in there, plug that one in there to hold it, and this is the valve. And the valve passes through that O-ring, that O-ring.
The accumulator tower will be 6 metres in length with an inner pipe, the white one, to 5 metres to feed the outlet with the correct head.
Top.
This is the connector in situ, showing the outlet and the connection to the inner pipe. And now, at last, for the pump, a doubled section of drain pipe. This is how you cut it with a straight edge all around. The second section was a reinforcement and had to fit round the first section. To do that, it had to be cut open and held wedged while the inner section was fitted.
Now,
when that worked, the next stage was to glue it in place. All hands to the pump, no pun intended, because the glue was very quick drying. It was also very volatile and noxious. The team thought about complaining, but you don't when you're high, do you?
for good measure.
Am I crossing everything?
Yes, they just stay there.
Oh, do you need that much?
Well, it'll squatch out, and I'd rather have too much than too little. Right. Woo!
The pump needed holes drilled along the top to allow the water to accelerate through. Another job requiring care and accuracy, because a tongue would fit below and at the right moment would shut off the water flow. This hole was to make room for a pivot for the tongue. That was the main pump body made. Then came the tongue, again a section of drain pipe.
I think maybe I cut it at a bit of an angle. There we are. Tongue. Because it's absolutely sweet, absolutely perfect fit. Because it contracts somewhat when you so that. And there, and that'll then lay in like that and go boom.
This is a reinforcement for the point where the tongue was to pivot.
Yes.
This is a reinforcement for the point on the tongue, which will carry a weight to ensure that the tongue will drop again after the pump has pumped.
Who knows, let's put a washer on first.
The copper pipe is a weight full of lead. Here's how John made his lead weight. Kirsten's away again, so it's back to the kitchen. The end of the pipe was plugged with heat-resistant cement and the pipe supported vertically. Lead was melted in a saucepan in the cooker. The process was quite primitive but effective. Then time to put the finished product on the plinth. Remember the plinth?
The weight there, and we slide this around here. And lever this on like that. Into position. Oops, this thing.
Back in the kitchen, John needed some more plastic components. Having heated some drain pipe, he needed the plastic flat. The components were cut out and heated for the next stage. They were glued onto the accumulator tower to hold the sight glass. The idea of the sight glass was by means of a float to see the level of water inside the accumulator tower. Eventually, after 5 weeks, came the first test at the dam at Automoo. Water was pumped up to a bowser on the hill.
Waiting for me to cover in water again.
When that was full, the water was allowed to flow to the reservoir barrel and then down to the pump erected at the roadside.
Working on its own!
Did you really have to do all that horrible thing there, John?
Yeah.
Why? That's a lot of waste on water.
See the shockwave?
Fine shot there. I think I lost something. I can't control it.
It works just as well because the civils are progressing on the Wickerman site, a dam to provide the head or an opportunity to play with water and get wet, a pipeline to act as a lade. Here's where Jamie has some fun making sure there's a clear entrance to the pipe. It wasn't warm. This is the business end of the pipe. We have water, but not much. So back to the paddling pole. But that's the fun of it. It's every wee boy's dream. Water to not to wash in, of course. Here's the pipe end underwater. There's about 45 metres of pipeline. Now it's John's turn for fun in the water. Yes, it was a happy time. Before setting up the pump on site, a few things were modified. Reinforcement for a handle on the tower and reinforcement for weights on the pump tongue and the pivot point. Strong, but small enough to keep it flexible. Reinforcement on the joint below the tower to cope with the shock wave.
Lay this on here and tighten it up with a tie wrap.
Finally, a good exit plug was made for the reservoir barrel to suck down the pipe. So, off to the site with the pump. Circumcision, I think we call this. Tamping a base for the reservoir. Ready to check the flow. It was disappointing. We had an airlock and drilled holes to let the air escape. Levelling the riverbed for the pump plinth. The tower getting connected. The pump getting set in place. And now for a test. This didn't look good. Not a first time starter. In fact, it kept stopping. And when it stopped, the shockwave bounced around the system and the reservoir acted like a relief valve. John played with the variables, well I mean he fiddled with the weights, and the pump started to work reasonably reliably, so it was left to run. The reinforcement stopped the joint flexing, and no flexing at this point either. It was certainly pleasing to get the pump running, because time was passing and the building of the Wickerman was progressing. Well, the pump ran for 9 days and stopped, and John wanted to know why. the pump had split open. The shockwave had caused the plastic to fatigue. This was more visible when the pump was dismantled. The base of the tower had suffered too. A new pump and tongue was made and reinforced with steel bands. On site again to make the final assembly. We got this one from a Laurel and Hardy movie. Another modification was to provide an air chamber at the base of the tower to cushion the shockwave. It also provided a little more height for the water head. Look, it started, first push. The reaction is softer. And this was promising enough to let John couple up the pipe to supply water for the cow and leave it running. Just in time, because the Wickerman was done. So John had to get the cow finished and delivered. It was to be made from old telegraph poles, plywood, plastic pipe, wire ropes, pulley and some odd bits and pieces. All to plan, of course. Dimensions and weights actually were critical. John is making the cow's neck. Really quite a substantial fabrication. The hole is for the pivot. It was to be made from solid bar, sleeved in an old scaffolding pole. Holes drilled in the cow's shoulders would support the pivot. Drain pipes would fill with water from the pump and make the neck overbalance and tip down. The pivot was really quite a tight fit, but it went eventually. Another tight fit was getting the neck to fit the cow. It took a lot of manoeuvring. Eventually it was there, with a little persuasion from a big hammer. So the neck was in place and the mechanism to move the tail, and the tail itself. At this stage the plan was to spray paint it, but that didn't work very well. So it was time to call in the cameraman again along with some cans of bitumastic paint. Weights were critical. This is how you weigh a cow's head using 30 kilograms of scrap iron, a spring balance and a pole. It turned out to be 41.5 kilograms. And then it got manoeuvred into place on the cow's neck. Some white paint and the cow was looking better. John built in a radius arm to the head to let it move more realistically with the neck. A winch takes the place of water here to let the arm works. Call in the artists who made light work of giving the cow a face. The flanks were a lot less arty. With counterbalances, pulley and links in place, there turned out to be a problem. It was diabolically stiff. Friction was killing movement. Suspicion fell on the neck pivot, which had its greasing improved, but to no avail. The answer turned out to be the pulleys, which were too small and too many. Larger sheaves freed the mechanism. Finally, the plumbing was installed, and the cow was coupled up to the water bowser. For the first test, there was quite an audience. This is the water filling the neck tanks. And the show begins. Everyone was very pleased that the cow had worked first time, particularly because the Wickerman Festival was to start the very next day. 4 p.m. on the day before the Wickerman Festival, and the cow is still not on site. It had been a ticklish job to get the cow on the trailer, and now the tree's in the way. On site and nearly there. Everyone is doing all the last minute stuff. So John had to get the cow positioned and coupled up. Starting the pump again to see if it worked. Good news, the pump was going. Water was flowing. The sap was rising up the cow's neck. And then movement. Looked good, but that was all we got. The cow had been strained and moving, and poor old John had to work well into the dark to get it to lift its head as well as drop it. John succeeded, and by morning all was well. Even time to look around the festival.